Hi, this is Warren Jones, and if you're listening to this, that means you've made it through almost the whole podcast. Episodes 3 through 4, just one more left. We thank you for joining us. This is, I know, a lot as far as terms, but it will be useful as we provide more interesting presentations in the future, covering various different applications of stored purpose technology. If you have additional questions, please visit us at wjones.com. And if you want to provide feedback, use the contact link. That'll help us decide which episodes we provide in order moving forward as we discuss the range of topics that you may see on the site. So thanks again. This is Warren Jones, and please join us again.
And here we're just showing the concept that agency, where agents will roam multiple devices. And indeed, we've gone through a number of different prototypes and form factors just to make sure primarily that the agent can do what it has to do. Because agent minds think in advance. They predict what's needed. So as you're working with an agent, oftentimes as you need something, the agent will reveal what it has already prepared for you. So to make that happen, which is a zero latency environment, there's some particulars in coordination where you still have to deal with some of the practical limitations of movement of information. So one of our goals, for example, was to be able to propagate intent from an agent to let's say a full-size display in less than 100 milliseconds, which means that you have to communicate wirelessly. You have to render the desktop in a tenth of a second, which if you compare that to loading your Windows desktop today, it's quite a bit different. So what we found that with the quality of the rendering canvases, again, we use a lot of WebKit, very light JavaScript, very good control and design of fonts. Yeah, we were able to do some things in as little as 40 milliseconds, particularly with the very good performance of our 802.15.4 and UDP communications work. Here we're just showing an agent roaming between home and office, and this is something that is it's a big leap. It's something I can't even go into the details because right now, but so it's hard to understand just how conceptually difficult that is to have an agent entity that's processing identity living on one network and then roaming to another network. So that's required a lot of thought work, and that's a good trick, we think. We think folks will really like that technology once it's available later in the decade. And just to let you know, we've thought about how the technology integrates with a lot of the commercial tools today. I personally keep my journal in a product from a company called LiveScribe, which I love, which is based on the same OMAP processor that we use for our prototypes. So, it's great because it'll record what you're writing and then you can put it to the computer. But we think it'll be a whole lot better if the agent's able to interact and then render back potential options, information on the e-paper as you're writing. So that you can write in your journal, you can think about thoughts. The agent can then go and retrieve pages, maybe from the internet, as you're writing your text. And who knows, you might even write to turn off the lights or to turn up the lights in your journal, and the agent will listen to you, and you just do a little dot command, as we call it, on the page, and the agent will take that action on your behalf. So those are cool things that are possible with technology that we know is already compatible with the designs that we're working on. Another thing that we'll talk a bit about, and this is something that we had to spend a lot of time on in our design efforts, is philosophy. It seems a lot of the good thought work about how to do what we're doing, particularly this idea of universal form that defines grass eternally, that work was done by Plato in 380 BC. And you know what? Not much has been done since. Aristotle, which was Plato's student, didn't believe that there could be a universal form. And darned if we didn't find, as we were defining the system, there must be universal forms. And indeed, if there weren't universal forms, you couldn't define in our DNA what a fruit fly is. And despite the many thousands of variations of fruit flies that you see, still always have a fruit fly after fruit flies mate. But indeed, that happens. And what we find that as another benefit of our modern internet society, that that any form that we define on our repositories, and let's say intelligentcomputer.org, and we put out there as a base form that, let's say, intelligent systems might adapt in the future, if let's say if you task your bot to start mowing the lawn, even though it thought it was a bot that was just delivering the mail, then those forms of what is grass and what's required to maintain a lawn, those forms become universal simply because we put them out on the web. So it's kind of interesting how old topics, very, very old topics, become very, very important when we're defining systems that are fundamentally intelligent. And then finally, we'll cover along the way, and actually we'll get to this pretty early on. A lot of people ask questions about stored program. In other words, the von Neumann architecture, all that we have known for 60 years, and say, what do you mean a different computer? And what I've realized, being a little older than some, is that those of us that were around in the 60s or 50s and were there when the first round of when computers were first invented, we were there when the inventors were saying, this is the first round version. There's going to be another version that's going to be more like humans. We're not going to get to it, but it's going to happen later. So we were all expecting back in the 60s these computers that would be mail delivery bots. We watched it on the Jetsons back in the early 60s as a cartoon show. But we have generations that have grown up since then that have no idea that computers were going to be able to do more, to be able to go out and explore space when humans didn't feel like it. We're going to be able to go and dig deep into the earth and find new energy sources. As we know, just 11 miles below us, there's energy and water galore for all our needs. So we find we have to take a step back, and we've written a couple papers sort of explaining what was stored program, and we think programs are going to be around for a long while, and ultimately programs become an important technology of stored purpose systems. They'll be using programs as their arms and their legs, their technologies, to do things like interpret pictures, to control parts of the lawnmower, for example. So programs don't necessarily go away. They just no longer have a place in the top part of the memory or the brain of the devices anymore. They're relegated to lower level program control systems, tools, technologies for the devices. So we'll talk a little bit about stored program and the history there, and what von Neumann, Eckert, Mauchly have developed. And that's actually going to be on our site this week. We'll have a couple papers out there going through the background of computers in general, and then specifically the background of stored program over the last couple years, and some of the challenges that we faced simply because we probably stayed with this technology a decade too long. Turing was just about right when he said that by 2000 we should have an intelligent system. 2000 was the year we really needed to do that, because the applications really became just so overbloated at that time, with each program having its own search system, its own database system, its own programming languages. I'm using a Google browser right now. It has Python built in. It's got its own search engines built into the browser. It's phenomenal what these applications companies have had to do to keep up with the expectations, because the underlying operating systems are kind of limited in their capacity. So the programs are really bloated up. So it's really time to move on to a new platform technology. And certainly in the enterprise world, where I spent the last decade as a CIO, you see that first and foremost every day, because there's so many different systems. Each different system is fundamentally different. It's not part of a same brain. And the information that's contained in the processes are very different. So you literally will have hundreds of different machines for the various different processes that you're running in a company, and each one may need a different person to maintain it. So we have all of these people servants to computer machines, and really what we're hoping to do is flip the paradigm a bit so that the machines become more servants to people. They're maintaining themselves and maintaining our information, and we're taking care of our homes, our family. We're taking care of oversight of what needs to be done. We are working from the crafts perspective, from the labor perspective. We're there because we know design, we know beauty, we know what we want. So we're still there involved, just like this wonderful talented Apple, Jonathan Ive, how he how he can make aluminum into a beautiful laptop. And I have a MacBook Air. I just love the device. But that type of design, that type of thought work, that hands on metal, is never going to go away. But what we'll be able to do with smart technology is to turn that image, that thought, that form, and we'll be able to convert that much more easily into the products that we want to have. And we'll be able to do that in a fashion that's more local. We won't have to always go to China to get something built for us. We'll be able to do it right here in our local communities, in factories that are just much more practical because we have the assistance of automation. So we'll talk a bit about governance and enterprise systems. And I think that's pretty much a wrap for the topics that we are looking forward to cover over the next few months.